Hi everyone, in this video we see how to create our own snake game in C++, and to do this we of course will use the CPP classes, which is the most important topic in object-oriented programming as C++. So first of all we create our class, so right click on the project, add class, and we call it, for example, SnakeGame, and so it creates by default the header file .h and the CPP file. And we've seen this also in my previous video, in which we create this day template class in as you can see in my solutions explorer. And okay, so first of all we include some header files and some classes that are already implemented in C++, for example the IOStream class, then the vector class, then the header conio.h, conio.h, and then finally we include the Windows header file, windows.h. Okay, we see this why we need this later on. Then we divide as usual our class in public part and the private part, and in the private part we need to declare all the variables we are using. So first of all, we initialize a Boolean variable that will tell us if the game is over or not, so that we know if the player can still play or if he lost the game and so we need to restart a new one. Then we need a couple of integers, width and height, that will set the dimensions of the playing field. Then we need some couple of coordinates. So first of all, the snake head, so snake head x and snake head y, which will tell us in which point of the playing field the snake head is located. Then the very same for the food, so food x and food y. With food I mean that for example we'll use the percentage symbol to simulate a couple of cherries, so whenever the snake head coordinates are the very same of the food coordinates, the snake tail will grow of 1. Okay, then we initialize the score of the player, and okay, for the snake tail we use two vectors, one for the x and one for the y coordinate, so we call them snake tail x and snake tail y, and then the snake tail length. Now we use this enum variable, which is very important, and we call direction, which will take the value based on which keyboard button the player is pressing. So the snake first will be stopped in the center of the field, and will we specify this later on, but first of all we initialize the stop as 0. Then we have one type for each direction, so left, right, up, and finally down. Okay, and then we initialize a variable of the direction type, we call it dir. Okay, and then we pass to the public part, and first of all we need a getter to see if the variable is game over, so we call it get is game over, and it simply returns the is game over variable. Okay, and we already seen this in my previous video, in which we create the date class, and I suggest you to watch it if you're not familiar with this, because in C++ it's mandatory to know classes, I'd say. Okay, then we declare four very important functions. So first of all, the setup function, then the print function. We see this in detail in the CPP file when we will write these functions. Then the input function, and finally the logic function. Just just to specify, for example, the setup function is uh, to see in which at which point of the play of the game the player is. Then the print function will print all the snake head and the snake tail, the food and the border of the playing field. Then the input function will read which button of the keyboard the player is pressing, and finally the logic part will see if the the move of the snake is regular or if the player has lost the game. Okay, so now we can pass to the CPP file. The only other file we need to include here is the snakegame.h, so the header file, but as you can see, Visual Studio has already done it. So we create the template for all all four functions. So void the snakegame setup. Okay, and we do this for all four functions. So okay, so setup, then we have print, then we have the input function, and finally the logic function. Okay, and now we start implementing the setup function. First of all, we have to set the variable isGameOver as false, since the game has to start. And of course, we set the score at 0. So isGameOver equal false and score equals 0. Okay, now we set the width and height of the game field. For instance, we can set the field as 20 times 12, but you can set whatever you prefer. So width equal 20 and height equal 12. At the beginning, we want the snake to be stationary and in the center of the field, as I said before. And to do this, we set the direction as stop and coordinate x and y as the two halves of width and height. So our variable dir for the direction equal to stop, and then snake head x equal to width over 2, and the same for the snake head y, we set height over 2. Okay, we now have to choose the initial coordinates of the fruit that the snake has to eat, and since we want them to be random, we use the rand function. And of course, we need to remember to set the srand time null in order to have a different random sequence for each call. Otherwise, the sequence of coordinates of foods would be the same every time you run the game. So we set as I said, srand time null. Okay, and now we say food x equal rand module width, and the same for food y rand, sorry, this is a percentage symbol, rand module height. Okay, and eventually we resize the tail coordinates with a general high number. For instance, we consider 100. That I think should be enough, but you can set it how much you prefer. So snake x dot resize, since it's a vector, and we set 100, and the same for the snake tail y. Okay, and as far as the setup function is concerned, we're done. Now we pass the one of the important function, which is the print function. And first of all, every time we have to clear the screen, so to write every element on the screen. So we say system CLS, which is clear screen. We now print the first line of the playing field, the enclosure of the playing field. So with a for loop for integer I equals 0, I lower than the width, and we set +2, and we'll see later why, and I plus plus, we std cout, and this is the upper bound, so we use minus symbol. Okay, and then we get a new line, so std cout std end line. Okay, we say +2 because the first element and the last element must be for the vertical lines of the playing field, the vertical enclosure, and so if we want a width, internal width of, for example, we said 20, we need 22 symbols. I hope this is clear. And now we iterate through the whole area of the playing field with two nested for loops, in which the external loop is for the height, while the internal one is for the width. So first loop, as I said, is for the height, so int I equals 0, integer I equals 0, I less than the height, I plus plus. Okay, and the internal for loop for int j equals 0, j lower than the width, and j plus plus. Okay. Now, if j is equal to 0, which is the case of the left side of the playing field, we cout, we print a vertical line. For example, I will use the exclamation point. Okay, now if the coordinates are the same of the snake head, we print a capital head, with a capital S, sorry, which in our case identifies, of course, the head of the snake. So we have to check if I is equal to the snake head X. Sorry, I is for the snake head Y coordinate, and the J is equal this time to the snake head X. We print the capital S, as I said before, which identifies the snake head, capital S. Okay, now we need to check if the coordinates are the same of the food. We print the percentage symbol, which with a bit of fantasy can be seen as a couple of cherries. So we say else if I is equal to the food y coordinate and j is equal to the food x coordinate, we print std cout, as I said, the percentage symbol. Okay, and in all the other cases, we have to check if the coordinates are the same as one element of the snake tail. So else we open the brackets since it's more than one line of code, and to do this we create a boolean variable. So bool, and I call it is snake tail coordinate chord, and we set it to false for the moment. Okay, now we iterate through the snake tail vector and check if the coordinates are the same. So for k equals 0, k lower than the snake tail length, k plus plus. Okay, we say if snake tail x of coordinate k of the kth element is equal to our j, and the snake tail y, the kth element, is equal to our I, then we have to do two things. First, we print the snake tail as we see as a small s, and then we set the boolean variable is snake tail chord equal to true, since it is the coordinates of the snake tail. And then outside the loop we say if not is snake tail coordinate, then we print a space, an empty space, std cout, an empty space. Okay, finally, if j is equal to the width of the plane field minus 1, which is the case of the right side of the plane field, we print again a vertical line, in our case an exclamation point. Okay, and yeah, now before going to the next height we have to get a new line. So outside here, sorry, this, I just have to check if the brackets are correct. Yeah, okay, so here we just have to std cout std end line to get a new line. Okay, and outside the for loop, yes, you see this is the here there is a typo with, and here I have to specify that it's an integer. Okay, this is the end of the for loop, and outside we finally print the first line of the plane field, the final line of the plane field enclosure. So for int I equals 0, I lower than width plus 2, as I said before, width plus 2, I plus plus, we still cout the minus symbol to identify the bottom line of the plane field. And okay, we just need to get some new lines just for a better scene of the game. And finally, all it's left to do is that below the playing field we can print the current score, which will increase every time the snake eats the charges. But we'll see this later in the code, in the logic function. So std cout, for example, score, and then the score variable. Okay, we get some new lines as before. Okay, and for the print function, we're done. Okay, now we can pass to the input function. In the input function, we manage the fact that whenever the keyboard is hit, we have to read which button is pressed by the player. And to do this, we need to include the windows.h class, but as you can see, we have already done here on the header file, so we don't need to include it again. And okay, the function we use is this. So if underscore kb hit, we stand for keyboard hit. So every time the player is pressing the keyboard, we have switch, and then underscore get ch, which stands for get character, which understands which character the player has pressed. Sorry, which button the player has pressed, and we have five keys, I'd say. So the first one, for example, is the W, the small W, in which the direction is up, and then break. And if you look at the keyboard, we say that W is for up, A for left, S for down, and D for right. And okay, so we do some copy and paste. Okay, as I said, so W is up, D is right. Then we have the A for left, and finally S for down. And we also add another case, which is simply the ESC button, which is specified as the 27. So here I can write it, so it's the ESC button, and we say if the player is bored and he wants to quit the game, we just set the variable is game over as true. So the game is finished, and then again we break. And the input function is simply like this, and then we can pass to the most difficult part, which is the logic function, but you see that it's not difficult at all. And this is also the actual part in which we let the snake game work. So first of all, we initialize some integer variables. For example, the first one is the previous x, prev x, in which we assign the snake tail x first element of the vector, so of 0. The same for the previous y coordinate. So here we have snake tail y, and we call it previous y. And finally, we need two new integer, which is previous to x and previous to y, which are the element before the last one. So we iterate through all the length of the snake tail, and we reorder the tail vector. So that the first element of the vector is the snake head. So first of all, we set these first two elements, snake tail x of 0 is equal to the snake head of x, and the same snake tail y of 0 is equal to the snake head y. Okay, we now iterate through the snake tail using a very simple for loop. So for integer I equal to 1, because the first element, the element 0, we already set in these two lines. So integer I equal to 1, I lower than the snake tail length, and this is the reason we need a variable for the length, and I plus plus. So prev2 x is equal to the snake tail x of I. The same for the y, so we can copy and paste. So previous tail y, and so previous to y and snake tail equal to snake tail y of I. Then snake tail x of I is equal to previous x. That's a very simple algorithm. So, and again, snake tail y of I is equal to previous y. Typo, okay, previous y. And finally, previous x is equal to previous 2x. So a very simple algorithm. And the same for the y coordinate. Okay, and we are done for the for loop. And now, depending on which direction the player is pressing on the keyboard, we have to move the snake according to that verse. So we have switch the direction variable, and we have some cases. So case left, we have snake head X. If you imagine, if you're pressing the left button, the snake head will move left. So we have to specify snake head X minus minus, so -1, and then break. We do some copy and paste of this, left, right, up, and bottom. Okay, so right is the same of left, but this time snakehead will increase the value of 1, so snakehead plus plus. Then we have the case up, in which the snakehead, this time y, will get minus minus because it goes up. And finally the case down, in which the snakehead will move down, so snakehead plus plus, snakehead y, sorry, plus plus, break. And finally we have the default case, which is simply break. Okay, and now we have to deal with the so-called Pac-Man effect, in which whenever the snake is meeting one of the limits of the playing field, it has to appear again on the opposite side of the field. So first, we do this with the left and right borders. So if the snake head x is greater or equal than width, then we get we set the snake head x equal to 0. Okay, and this is for the right borders. Then if for the left border, if the snake head x is lower than 0, we set the snake head x to be equal to width minus 1, of course, because the width element is exactly the right border, so we get -1. Okay, and here I missed an S if, but it's not mandatory. And now we do the same for the up and bottom borders. So if the snake head y is greater or equal to the height of the playing field, we set the snake head y to be equal to 0, so it reappears up. And else, if the snake head y is lower or equal to 0, we simply get snake head y to be equal to height -1, for the very same reason of the width. And here we're done also for the up and bottom borders. And okay, up to here there is no way left the game to let the game finish, but unless considering the pressing the ESC button on the keyboard. So we need to add the rule that whenever the snake head intersects one element of its tail, so it hits himself, let's say, the player loses the game. And to do this, we have to check every element of the tail. So we need to use again a for loop. So for integer I equals 0. So then for integer I equals 0, I lower than the snake tail length, and that's the reason we need this variable, and I plus plus. We open the bracket since we're doing more than one command line. So if, no, maybe it's not even necessary because we'll have two lines, but it's just one if. So That's okay. So when this happens, we set the game over variable as true. So whenever the snake tail x of I is equal to the snake head x, and the same for the y variable, so we copy and paste it. Snake head y equal to the snake tail y of I. We set the is game over variable equal true, so the game is over. Okay, now the only thing left, which is the last part of this logic function, is to add one element to the snake's tail whenever the head eats the cherries. So whenever the snake head x is equal to the food x and the snake head y is equal to the food y, so both the coordinates are the same. Now here we need the bracket since we've done more than one command line. So first of all, we increase the snake tail length of 1, so snake tail length plus plus. The same for the score, so score plus plus. Then after this, of course, we have to print the cherries in another point of the playing field. So for the same reason as before, we need srand time of null, and then food x is equal to rand module width, and the same for the y coordinate. So food y is equal to rand module height. And okay, the logic function is done. We just need to write our main part of the code, so int main. First of all, we need to create our variable of type SnakeGame, which is a class we already just implemented, and we call it snake. Then we have to use the setup function of the SnakeGame class to initialize all the variables and the width and height and the playing field and so on. And then we have while not is game over. So while is game over variable is set as false, we write it as snake while not, which is the exclamation point, snake dot get is game over, which is the reason we needed this getter. We have to snake dot print to print the playing field and the snake head, tail, and so on. Then snake dot input to read what button the player is pressing on the keyboard. Then the snake dot logic to see if the direction is playing is correct, if the snake head intersected snake tail, so the game is over, and so on. And finally, we use this sleep of 10 to just to slow down a little bit the game, otherwise it would be too much fast. And we're done. We just need to test our function, so we restart, we compile, and we build and compile our solution, our project. Okay, it seems that it's actually working. As you can see, I can move up, down, right, and left wherever I want, and whenever I eat the cherries, the snake tail is growing, and it follows, of course, the snake head. If I move from the right side, the snake appears on the left side, and we implemented all the most important features of the snake game, so it's actually working. So I hope you enjoyed this tutorial, and you have fun while playing the snake game, and see you in the next video, and thanks for watching again.